Okay, so Eg2. So we're given a function, a Cartesian equation, 2x cubed plus 3x squared minus 12x. So I can see it's cubic, so I know that the curve is either going to look like that, or look like that, or possibly look like that. So that's the sort of shape when I come to sketch it that I'll be expecting. So part 1, find dy dx. So differentiating the original expression, I'll get 6x squared plus 6x minus 12. And find the values of x for which dy dx equals 0. So that means we're looking for the points with 0 gradient, hence stationary points. So when dy dx equals 0, then 6x squared plus 6x minus 12 equals 0. So we need to factorize that, but that's no sweat anymore because of our super duper calculators. So if we go to menu, down to equation function, enter. It's a polynomial we want to solve, and it's a squared, so it's of degree 2. The x squared term is 6, the x term is 6, and the number term is negative 12. So the gradient would be 0 at x equals 1 and x equals minus 2. You may well be wondering there, well, what's happened to the 6 or something more complicated, but I could have divided throughout there by 6, couldn't I? I had an x squared, x minus 2. So I would have done that if I was factorizing or solving by inspection, but we got the calculators, so why not use them? So going back to this, find dy dx, done. Find the values of x for which the gradient function is 0, done that. Find the second derivative, find the value of d2y dx squared at each stationary point, and hence determine its nature. So I know I've got a stationary point at x equals 1, and I know I've got a stationary point at x equals minus 2. So d2y dx squared will be 12x plus 6. So at x equals 1, d2y dx squared will be 12 lots of 1 plus 6, which is 18. 18 is greater than 0, so that's telling you that there's a minimum value at x equals 1. At x equals negative 2, d2y dx squared will be 12 lots of negative 2 plus 6. Well, that's going to be minus 24 plus 6, which is minus 18, which is less than 0, therefore a max at x equals negative 2. So the curve that I'm going to sketch is going to be looking like that one. It's going to have a maximum before the minimum. So we've done that. Part 3. Find the y values of each of the stationary points. So to find the y values now, I need to go back into my original expression, original function, to work out the y that corresponds to the two stationary point x values. So in 1 at x equals 1, y would be 2 1 cubed plus 3 1 squared minus 12 times 1. So that's easy enough to work out. We've got 2 plus 3 is 5 minus 12. So 5 minus 12 is minus 7. So now we can say, therefore, the max is at 1. Sorry, the min, not the max. The minimum is at x equals 1. So there's a minimum at the coordinate 1 minus 7. And then at x equals negative 2, y equals 2 times minus 2 cubed plus 3 times minus 2 squared minus 12 times minus 2, which we can evaluate as well. But let me just show you how we could use our calculator. If we go back up to, actually put it on the screen, it would help. Go back up to the calculate, and if we store minus 2, store in x. Okay, so I've got the negative 2 stored in x. I could then just type 2 x cubed, which I thought there was a button for. Yes, there is. There. So 2x cubed plus 3x squared minus 12x, just like it's written, and press equals, and you get 20, which is the y value. So you can work it out, no problem, but what I'm trying to do this year is to try and make you realize how powerful these calculators are and how you can use them to your advantage. So therefore we've got the max at minus 220. Let's go back to the question. So find the y values of each of the stationary points, sketch the curve given by that expression, for that expression. So as far as that is concerned, I know where the coordinates of the maximum and the minimum point are. What I could do with now is knowing where the curve crosses the x and y axis. So it's going to cross the y-axis when x equals 0. So if you put x as 0 into equation 1, you can see that y is 0. And then to find out where the curve crosses x-axis, we want to know when y equals 0. So in 1, that means we've got 2x cubed plus 3x squared minus 12x equals 0. Now on first sight you may be thinking, oh no, this is a factor theorem question, but it's easier than that because we've got an x term in each. So I can take the x term out, and that leaves me 2x squared plus 3x minus 12. And this I can factorize by again reversing or solving the quadratic equation. So 2, 2, 2, 3 minus 12. So that doesn't work out to be very nice, does it? Okay, so this is probably one then that they're not even looking for you to work out where it crosses the x-axis above and beyond that. because what you've got is either x is 0, which we already know, or x is, and let's round it off, minus 3.3, or x is go back to the start. Minus 3.3 or minus 0.75. No, let's put that back in. So I've got 2, 3, and minus 12. So, or x equals 1.8. So to sketch that now then, what this is allowing me to do is to know that I've got a graph that's doing this. It's going to have a maximum value there of 20 and minus 2. That value is minus 3.3. Here's 0, 0. The minimum value is 1 minus 7, and this point here is 1.8. So those are all the key bits, and that's all the sketch has to be. It's not plotting it, it's not accurate, it's just the shape of it plus the key coordinates that define the shape. So that's its maximum and minimum values and where it crosses the axis. Now the other thing I just noticed with the clever calculators, let's see if this is correct. So I want a polynomial, and this time it's cubic, so I'm going to put a 3 in there, and then my x cubed term is 2, the x squared term is 3, the x term is negative 12, and the number only term is 0. So that's telling us that it's crossing the x-axis at 1.81, which we've got. It's crossing the x-axis at minus 3.3, which we had, and also at 0. So let's bring my sketch back in. Oh, it doesn't go on with the quadratic one. It was telling us there what the maximum and minimum values are. It's not doing it for the cubic, which is a shame, but it is telling you the 3 points that crosses the x-axis. Anyway, the key bit to that really is your ability to sketch the curve and using the second differential to determine whether it's maximum or minimum, rather than what you'd have to do in AS, where you'd have to take a point either side of that and substitute in, and then a point either side of that, which gets quite tedious.